All right, so 3-2 is extremely similar to section 3-1. The only difference is we're still looking at a transversal intersecting two or more lines. But this time the lines that we're looking at tend to be parallel. So special things happen when a transversal intersects parallel lines. So here's one of our first postulates. Postulate is something that could be proven but isn't. If two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So you're going to want to draw a picture along with this. So the picture along this would be here. And corresponding angles are angles that are in the what? How would you describe corresponding angles? So, what did you say, Carly? You didn't say anything. Say it again. Same position, right? So if this is an angle, its corresponding angle would be there, correct? So one thing, and wouldn't you agree that they would appear to be the same measure? They're both, in this case, obtuse, right? If I told you that this angle here was 120 degrees, what's this angle here? 120, because what kind of angles are they? Vertical. What's this angle's measure? 60, because these are what? Supplementary or linear pair. And so what's this angle here? 60. So if these lines are parallel, then this also becomes 120, and couldn't I do the same thing in this grouping? All I would need to know is one angle measure, and I can find all 8 if the lines are parallel. So that would be 120, that would be 60, and that would be 60. Theorem 3.1 says if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So your picture for that one. Alternate interior means it's on the inside and they're on alternating sides of the transversal. And so the two that I chose there both happen to be, it's a pretty sad arc, both happen to be acute, and they will be equal. These, by the way, are reasons in your proof. So if I'm saying in a statement that angle 1 is congruent to angle 5, my reason would be, quite possibly, if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. There is no shorter way to say that. So you're going to have to learn them. Don't these two say exactly the same, except instead of corresponding angles, we replace with alternate interior angles? Right? So once you learn one, you've learned most of them. There's only one that's different. Here's the one that's different. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. Here's why they're not congruent. Here's a picture. Consecutive interior angles mean that they're inside the parallel lines and they're on the same side of the transversal. So here's one, here's the other. So I've given you a single arc mark on one and a double on the other. This one's acute and that one's obtuse. Is there any way that they can be congruent? Well, there is one way. What if my transversal is perpendicular? Won't you just have all right angles? It's the only time that they would be congruent. 100% of the time, your consecutive interior angles will be supplementary when the lines are parallel. Make sure you draw your pictures to go with these. Theorem 3.3. Theorems are proven, postulates are not. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. So this one is just like the first two. So alternate exterior means that both angles are on the outside of the parallel lines and they are on alternating sides of the transversal. So this would be an example of a pair of alternate exterior angles. When the lines are parallel, they will be congruent. And then the last one is different than all of them. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. This is used a lot, and you forget it all the time, mostly because we're not studying our theorems, or we're getting them all mixed up. But all this is saying is in a plane, if a line is perpendicular, and we're going to assume that these lines here are parallel. So if a line is perpendicular to one of two parallel lines, then we're going to make the assumption that it's perpendicular to the other. Mostly we can use this postulate right here to prove this, because what kind of angles would these two right angles that I've marked there be? What kind of angles are they on parallel lines? Well, it doesn't matter what kind of lines. When two lines are cut by a transversal, what would you call the relationship between those two angles? Are they alternate interior angles, alternate exterior? They're corresponding, aren't they? If corresponding angles are congruent, the lines are parallel, correct? But in this case, because the lines are parallel, these angles must be congruent. If that's a right angle, that's a right angle. And if these are right angles, then the two lines connecting them or creating the right angles must be perpendicular. So there is a full formal proof behind that, which you might get the joy of doing. Yay. Yippee! You can't wait, right? All right, so find your yellow sheet when you're done with that. Can you erase this? Everybody good? All right, now that we have our theorems out of the way, basically what we have discovered is that all angle relationships are congruent on parallel lines with the exception of which ones? Which ones are not congruent? Consecutive interior angles, what are they? Supplementary. You just learned these four right here. And the other thing you've learned is if a line is perpendicular to one of two parallel lines, then that line is perpendicular to the other line as well. So that's one you're going to have to study also. Okay, let's look at this. So let's start finding some of these. Find your alternate interior angles. I'm going to write them right here. On this picture, which are your alternate interior angles? So these are my parallel lines, right? So 3 and, here's my parallel lines, 3 and what? Alternate interior. 3 and 5, they have to be on alternating sides, right? So angle 3 and angle 5, is that the only pair? And then 2 and 8, right? So angle 2 and angle 8. Alternate interior angles are what to each other? They are congruent. So you can put a congruence marker in there. Then corresponding angles. So name all the pairs of corresponding angles. Start with 1. Angle 1 is corresponding to what angle? 7 would be alternate exterior. So this is in, if you think of it this way, tilt it this way, isn't this in the upper right position? What's in the upper right position here? 5. So we've got angle 1 and angle 5. Angle 2 and angle what? And 6. Does everybody see that? Angle 3 and angle what? 7. Angle 4 and angle 8. corresponding angles are what to each other? So look at angle 1 and angle 5. What do they appear to be? Because I'm looking for congruent or supplementary, right? So they appear to be congruent because they're both acute, right? So again, these are congruent. Then let's look at your alternate exterior angles. Name a pair of alternate exterior angles. So here's your parallel lines. They have to be on the outside of those parallel lines. 1 and 7. Whoops, I guess I should put angle 7. So that's one pair. What's the other pair? Angle 4 and angle 6. Alternate exterior angles are what to each other? Look at those angles. Congruent or supplementary? Congruent. Then let's look at same side interior, or I prefer consecutive interior. So give me a pair of consecutive interior. Here's your parallel lines. They have to be on the inside, right? What's same side or consecutive? Angle 3 and angle what? And 8, same side, right? And then angle what and what? 2 and 5. So look at 3 and 8. Are they congruent or supplementary? Supplementary. What does supplementary mean? They add up to 180 degrees. All right, so then let's look at same side exterior or consecutive exterior. We didn't actually talk about this yesterday, did we? But I told you that it was kind of there. We did alternating exterior, right? So 1 and 7 would be alternating exterior. So what would be same side exterior to angle 1? 6. That makes perfect sense, right? And then what's another pair? Angle 4 and angle 7, because they're both outside and on the same side of the transversal. Now look at 1 and 6. Are they going to be congruent or supplementary? Is this acute or obtuse? It's acute. Is this acute or obtuse? Obtuse. Can an acute and an obtuse angle be equal to each other? No. So what do you think they are? Supplementary. And you might want to put in there again, that's 180 degrees. Then, so all of these have that relationship when a parallel line is, when two pairs of parallel lines are cut by transversal, or a pair. These down here occur no matter what. These occur whether or not the lines are parallel. You still have vertical angles, you still have linear pairs. And by the way, you still have alternate interior angles and all of these other angles. They just may not be congruent or supplementary. You still have those angles, but they don't have that special relationship if the lines are not parallel. So let's look at these. Name all vertical pairs. All of them. So angle 1 and 3. Angle 2 and 4. Angle 5 and what? 7, right? And angle 6 and 8. What do you know about vertical angles always, no matter whether the lines are parallel or not? They are always congruent, no matter what. And then, okay, there's a lot of linear pairs. We're just going to put an example because we don't have enough room here. So here's just an example. What's an example of a linear pair? Angle, what? Angle 5 and angle 6. Would you say that they're a linear pair? They form a straight line? Sure. Angle 5 and angle 6. Linear pair of angles are what? Supplementary, always, by definition. So there's a good graphic organizer for all the postulates that you just did, with the exception of the perpendicular one. Now let's apply this. Are you ready? Okay, so flip it to the back. Let's do some problems. So this says in the figure, remember lines can be written with a cursive lowercase letter. So in the figure, line P is parallel to line Q. They've also given you dark arrows in there. That's also indicating that they're parallel as well. And the measure of angle 11 is 48 degrees. That should be degrees. And so I'm going to find angle 11, and I'm going to put 48 degrees in here. You should be drawing on your pictures. So your homework assignment tonight is out of the textbook. So what you need to do is not draw on your textbook. You need to redraw the picture on your paper and draw on that picture. So if I don't see these pictures redrawn on your paper on your homework, I won't be giving you credit because that's part of you showing your work. Plus, you need to not do it in your head and do it on paper. If you have it all on paper, your brain can relax and it doesn't have to think so hard. So we have to find the measures of all these angles. So starting with this one, it's like dominoes. What can I find and why? If this is 48 degrees, what else do you know? So raise your hand so I can see. Haley. How do you know that angle 15 is 48 degrees? What's the relationship? Alternate interior. So we're going to put 48 degrees here. What else? 13 is what? 13 is 48. Why? Because they're vertical angles. So 13 is 48 degrees. What else can we find and why? 14 is what? 132. Why did you get that? So these two are a linear pair, or these two are a linear pair, right? So angle 14, we didn't have to find it. That's okay. Well, we would have found it anyway, because we're going to find them all.
Yeah, that's right.
So what does angle 2 equal? 12. Angle 12. 132. Why? They're vertical. All right, so we've got all four of those, so let's work here. What can we do here? What can we do? You have to do this on your own. I already know the answer. So 9 is what? Everybody. Why? They're vertical. I'm trying to get you to identify the name of that angle or the relationship that that pair has so that in your brain will click, are they congruent, are they supplementary? And so 9 is 48 degrees. What else? We can find 10 and 16. We don't have to over here, but we're going to. What's angle 10? 132. The linear pair to 9, right? And so what's angle 16? 132. Okay? So how are you going to get these? What did we not put in over here? Yeah, it was kind of important to not miss that, right? So the measure of angle 1 is 107 degrees. We cannot assume that this line is perpendicular if it's not told to us, and sure enough, it's 107. Your textbook likes to draw pictures so that they appear to be one thing and they're really something else. So it's like your eyes are warring with what you know is going on in your brain. So they love to do that to you, so be careful. So if angle 1 is 107, what else can I find? Angle 7 is what? 107 why? Vertical. So we didn't have to find that up there. What else? Angle 2 is what? 73. Why? These two are supplementary and those two are supplementary. What else can we find? What's angle 8? 73. Because it's vertical to that one. What else can we find? We have to find 3, right? So what's 3? Why? Yeah, so you can say it's alternate interior to this one. You could have said it's corresponding to this one, right? Or you could have said it's consecutive interior to this one and that they're supplementary. There's a lot of different reasons why we could have said that. But 3 is 107. All right, so what's 5? 107y. Vertical, right? So what's 4? 73. And of course 6 would be 73 also, right? Okay, so now we have to find 17. How are we going to find 17? What you thinking, Kappa? what if I drew this in for you? Easy to miss, isn't it? Because you're not thinking there, you're not thinking that, but they're pulling in some previous information, aren't they? What do we know about the interior angles of a triangle? They all add up to 180 degrees. So what does 73 plus 48 equal? 121. So how much is left over out of 180 degrees? 59 degrees. And you might want to write in here that this is 180 minus 73 plus 48, because you might forget how we got that, which is equal to 59 degrees. Any prior information always comes into play when we're doing problems. We're never allowed to forget it. All right, so let's look at the next example. Now we're going to find x and y. So just by the picture, we know that these lines are parallel. They're parallel lines inside of a triangle, correct? So not only it's a triangle, I know that all three of these angles here are 180 degrees. It may or may not come into play. But I also know that these lines are parallel. What is the relationship between these two angles right here? They are supplementary. So one equation that I could set up is that 3x plus 11 plus 3y plus 1 is equal to 180 degrees. Can I solve an equation with two unknowns? No. So is there another relationship that I can set up? Because this angle right here and this angle right here, those are a linear pair, and I could do the same thing, right? 4x minus 5 plus 3y plus 1 is also 180 degrees. Does that help me? No. So can I set up an equation where I have only one variable using my angle relationships? Taylor. What is the relationship between these two angles here? What kind of angles are they? They're corresponding. Aren't they in the same position? If we extended out this line here and this line here and the transversal down there, aren't these in the same position? Isn't this in the upper right and this is in the upper right? So they are corresponding angles, and immediately what's the conclusion? Oh, they're equal. So now you can set up the equation to solve. So now we've got 4x minus 5 is exactly equal to 3x plus 11. So we're going to solve that. Subtract 3x. I get x minus 5. Josh here. Add 5. X is equal to 16. So now I found x, correct? Finding x, can't I plug it in for x in this equation and find y? Right? So that's what we're going to do. For the 1y, oh, I'm just putting the wrong one. There's my y. My x is going to be 16. Equals 180. So what's 3 times 16? 48. What's 48 plus 11? 59 plus 3y equals 180. So subtract 59. I get 3y is equal to 121. Does 3 go into 121? What's 1 plus 2 plus 1? 4. Is 4 divisible by 3? No. So we don't get a happy answer. Did I do something wrong? Oh, I didn't add my 1. Thank you. So it's 60. Fix it. Something like that. So this should be 60. And so that makes this 120, right? Now will 3 go in there? How many times? 40. That's much better. That's what I get for doing something in my head. Oh, and then add your 11 plus, or your plus 1. All right, so then look at the second problem here. We've got a 6y, a 13y minus 10, and a 9x plus 12. I have to find x and y, but I'm going to start off with setting up an equation that I have the same variables in. So find a relationship where they have the same variables and think, are they equal or are they supplementary? What about these? Can I set that up? No, they don't have the same variables. But these two have the same variables. Do they have a relationship? What kind of angles are those two? Consecutive interior angles, right? Are they the same or supplementary? We've got an acute and obtuse, right? So they have to be supplementary. So I'm going to take 6y plus 13y minus 10 equals 180. Collect your like terms, we get 19y minus 10 equals 180. Add 10, 19y equals 190. Divide by 19, what do I get? Are you guys asleep today? I think we're asleep today. So how am I going to find x? If I were you, I'd plug it into here. Then these are supplementary, right? Or you can plug it into here and these are equal. What do you want to do? Which one? The 6y? Okay. So, because that would be easy, right? So, what's 6 times y? 60. So I know that this angle measures 60. So what does this angle measure have to be? 120. So that means this equals 120 degrees. So this is an easy equation right here to solve. Don't we subtract 12? So we get 9x is equal to what? 108. And then divide by 9. X is equal to 12. Okay, look at number 8. I'm going to do as many of these as we can get to, because these are the parts that are difficult for you. So you want to identify an angle relationship, preferably if they have the same variable. Those are the ones I'd be setting up. So I wouldn't be looking at that angle relationship, but I would be looking at this angle relationship here. What do you know about those two angles there? This one here and this one here. They are supplementary. Don't they form a linear pair? Don't they together make a straight line? That one's a hard one to see. So we're going to go ahead and set that up. So we have 3x plus 5 plus, is that a 6x? I drew on mine. Is that a 6x? Yeah. Okay. Minus 14 equals 180. So collect your like terms. 9x minus 9 equals 180. Add 9. 9x equals 189. Divide by 9. And you get 21. And you're going to find y. We'll find an angle relationship. These ones here are equal, aren't they? So if I know that x is 21, can't I plug it into 3x plus 5? What's 3 times 21? 63 plus 5. So this is 68 degrees, right? Doesn't that mean that this is 68 degrees? That one's easy to solve for. What's y? What is it? 60. Subtract 8 from both sides, right? All right, look at 9. Here's my parallel lines right here. So they've got them sideways. If you don't like looking at them sideways, turn your paper. What's this little marker here for? 90 degrees. So that, I know that's 90. What else do we know then because of that? Yeah, this is 90. Don't we have a theorem that says if the transversal is perpendicular to one of two parallel lines, isn't it perpendicular to the other parallel line? Right? So that means that all of these are 90. So that's a quick shortcut to setting up our equations to solve, right? So that means that 9y is 90. So what is y? 10. That means that 5x is also 90, because all of these angles along here are 90. So what is x? 5 goes into 9 once with 4 left over. 5 goes into 40 how many times? 8. So 18. So that one was easy as long as you made the connection with the theorem of postulate, right? All right, look at 10. Now we have a parallelogram. You're going to learn more about parallelograms later, but for right now, here's your parallel lines. What do you know about this relationship here? They're supplementary. Do they have the same variable? Yep. What about this relationship here? They're also supplementary. So we're going to add them together and set them equal to 180. So I'm going to start with the left side. So we've got 6x, right? Plus 8x plus 40 equals 180. I'm pretty sure that if you can set up the equation to solve, then you can solve it algebraically. The tough part is writing that equation. Add your left-to-right terms, 14x plus 40 equals 180. Subtract 40. 14x is equal to 140. Divide by 14, don't you get 10? Do the other side on your own. Josh. You get 19. So now that we've done all of these with the last two, I want you to do the last two on your own. I'll put the answers up here in a minute, but I want you to work those on your own, see if you can figure out the equations to solve, the relationship between the angles, show as much work as you can. I'll give you about 5 minutes. You can compare answers around you, should you need to. So compare around you. Are you ready? So here's number 11. Now you might not have gone in the same order or used the same relationships, but I chose to look at these two. No, I chose to look at these two. Aren't those two consecutive interior? So aren't they supplementary? All right. So I took x and 72, added them together, set them equal to 180, so that means x is 108. So that's 108. If that's 108, aren't these two here, right there, corresponding? So that means that 3y is equal to 108. So divide by 3, you get 36 for y. And then these are also corresponding right here, because you got two sets of parallel lines. So that means that 3z plus 18 was also 108. So if you subtract the 18, you get 90, and divide by 3, you get 30. Now you might have chosen to go a totally different route, and that's fine. Are you okay with that? How'd you do? Okay? Do you understand any mistakes you made? Okay. Then look at this one. I started off with this angle here and this angle here. Aren't they on the same side of the transversal? Aren't they on the interior of the parallel lines? So they're consecutive interior. Doesn't that mean that they are supplementary? So I added them together, solved, and y became 93. So then, then I looked for x, and this transversal, by the way, cuts into z. Well, z, you have to be careful with what you use for relationships here. But notice that this is a right angle marker. That means that its corresponding angle is right here. And if this transversal is perpendicular to this parallel line, then it must be perpendicular to this parallel line. So that's 90, that's 90. These two angles together are 90. Those two angles together there are 90. So x turns out to be 90. And then you could have done a couple of different things to find z. You could have realized that those two are 90, and you could have figured out, well, if y is 93, 93 minus 18 is 75. So that means that this angle here is 75. You could have done 75 plus z is 90, or I just did this all three of these angles together and make 180. You could have done that as well. So 75 plus z plus 90 is 180. Subtract your 90, you get 90, so you're back to what you would have if you had just looked at those two. And then subtract 75, z turns out to be 15. The more of these you do, the better you get at them. If you ignore them, you'll never get good at them.